but it just, it feels also good to be able to badger people for fun and profit. Part of it. All right, it's 10 o'clock. I guess we should get started. So if somebody could volunteer to take notes, and I'm looking at the remote participants who there are 17 of you, well, 16, I guess. So if anybody could step up and volunteer to take notes, that'd be very, very helpful. There's a note-taking tool in right there in Meet Echo. It's very, very easy to log in and use. Anyone? Thank you, Christopher. Perfect. Christopher Ignacio has volunteered to do that. All right. So, Jaron, I think we can sort of just get the show on the road at that point. So, this is the session. Let's get to the note well. Note the note well, as the saying is. And Jaron, this is usually when you tell people to sign up to Meet Echo.
Yeah, this is where you tell local people, of which there are very few, to use the local tool, the in-person tool, and then remote people already know what to do because they're here.
Exactly. All right. Well, we have a note taker, and hoping we get good notes in HedgeDoc. And I think with that, the agenda, so we're basically going to have Justin up here talking, and he's also going to attempt a live demo from tempting the gods of the demo gods to see if we can actually do a live demo based on the hackathon, which is going to be fun. But we have a lot of stuff to go through, so I think we'll just invite you up, and I'll switch the slides over to protocol update. And let's see here. Embedding editor's update. There you go. There we go. Do you want to
do the slide control thing? Yeah.
It's just too advanced.
What's this stupid OpenID thing it makes me do every time? Come on.
Yeah.
All right.
I wonder who came up with that stuff.
Yeah, that stuff's dumb. All right.
Yeah.
So I have requested control.
How do I see that?
I think it's the thing that's lit up.
I don't see anyone asking me for.
Oh, right there. No?
No. Where's the list? Go to the list.
Oh, there we go. There we go.
Gotcha. And now I should have slides.
Magic. There we go.
There we go. Awesome. All right. So, good morning, everybody. Welcome to the last day of IETF 113. I am going to be presenting all of the presentations today because Fabian was unable to travel here in person. He's online, though, I saw. And Aaron was unfortunately unable to make it this morning. He is also online and will be jumping in from time to time. So, first off, we are going to go through the protocol update. Going to go through the changes to the core draft since IETF 113. That's from version 8 to version 9. And including all of the editorial and functional changes, because there's been a fair bit. And I want to take a pause to say that we have not been focusing on the RS draft during this time frame. The reason for that is that there's still been enough sort of editorial and structural stuff that has been happening in the core draft that the editors didn't want to split our focus and split our attention too much right now, because the two drafts are intended to work fairly orthogonally with each other. So the idea being we can get the core draft even more solid and then start focusing on the RS draft in the future. All right. So if you download the slides, all of these links are live. You can go and look at the actual diffs between all of the different drafts if you're curious about the actual text that we changed. We did 37 pull requests on the core draft and 2 on the RS draft, although we did not publish a new version of the RS draft in this time frame. And again, if you go click on those live links, that'll actually pull up a list in GitHub of everything that's changed during that time so that you can see the actual changes with all the commentary and everything like that. All right. We managed to close 40 issues in the core GitHub tracker in this time frame. Again, you can go look at that list yourself, see all of the things that we've managed to close. Almost all of those are closed with actions that are tied to one of these pull requests. A few of them, they were either duplicates of other issues, and we tied the conversations together, or things like that, or we went and read through them and decided and brought to the group the fact that this has kind of been overrun by events, or there wasn't consensus to make the changes requested or something like that. But for the most part, the issues that we've been closing, we are actually making changes into the text to make it more consistent, to make it more readable, and to make it more robust overall. And no issues closed on the RS draft. So on the editorial side, things fell into 3 different categories. First, and this is a big one for a draft this big. I forget our page count right now, but it's a very extensive draft. Text consistency is going to be a really, really big thing, because sections get written at different times by different authors, by different people and stuff like that. So there have been a number of things over the last 6 months, so the last IETF period and this period, where we've realized that we haven't been using terms correctly, or somebody asks, like, why do you call it this here and that there, and stuff like that. And most of the time, there's actually not a good reason. And so there's been a lot of cleanup on that. So 2 big issues for that. The ones I want to point out is, use of the term end user, and use of, I'd have to click through to remember what the other one was. Anyway, again, these are all live links. Thanks to Aaron's editing on all the slides. These all actually link into GitHub, the actual GitHub issues and pull requests. As you can see, there's a lot of editorial stuff that went in here. These are typos, these are formatting, these are, little bits and pieces. And then finally, a lot of what we just put under cleanup. Like, it's not even really changing editorial text, it's shuffling headers and things like that. Functional changes, we actually had a few good ones, and I'm going to go into a couple of these categories in more detail as part of this presentation. Actually, if you guys don't mind, would you guys mind if I took my mask off while I'm talking, because trying to project in a mask? All right, thank you. Thank you. Trying to project in that mask is a little difficult. So we have a very extensive security consideration section now. It's obviously not complete, because it's a security protocol. There's going to be a lot of security considerations. But we added sections on a few new attacks or newly identified attacks, and either the mitigations or the descriptions about them are now in the security considerations. One of the things that we did with the security considerations in this round, and tied a little bit into the last revision as well, was we tried to make sure to have forward links from the from the actual normative text that was making the requirements and forward link into the security considerations that explains why you would want to do that or the additional things you might want to think about and talk about. We made some changes to the subject identifier formats. I'll talk about that in a sec. That's tracking work in the SEC event group that is wrapping up hopefully real soon right now. We did a bit of work on keys and discovery, some changes in how in the interaction section. And I'll be talking about the changes in the user code mode specifically. And those of you that were in the OAuth working group, this will, you know, this ties into some of the discussions that have been happening there as well. We finally have error codes, thanks to Aaron. And I totally take the blame for us not having error codes up until now because I got into the lazy habit of saying it returns an error and linked to the to be defined error section. So Aaron went through and created the error code section and sort of established the pattern of what these will look like. And we're still kind of backfilling some of the places in the spec that need to define specific errors, but I think we've got a lot of them done right now. And we had a couple of different changes to how token management works, and I think we're going to go over those in a bit. All right. Oh, here we go. That was the other change. I forgot Aaron was supposed to do these slides, so my bad. So on the editorial side, we were more deliberate and consistent about the use of URI versus URL. Anybody who's tried to get something through the IESG knows that we would have been raked over the coals for this anyway. So good to at least try to be consistent and correct about that now. Turns out most of the places inside Gnap don't really need a URL. So almost everything is a URI inside the spec space. And the use of end user without the dash as opposed to end user with a dash. And one of the big ones for readability that I think is actually, you know, it's one of those improvements that you don't notice until you're reading text that doesn't have it, is the parameter lists are all listed now in such a way that things are actually consistently listed out in terms of what the parameter is, its description, and whether or not it's required. All right, so user code interactions. Previously, we had this kind of wishy-washy text about the user code interaction mode that said that you return a user code for a user to type in, and then a URI which shouldn't vary, but it was kind of allowed to. And if it did, then maybe you should do something about it, but the client wasn't actually required to do anything with that because the client was supposed to be able to count on that being static and all this kind of stuff. We've realized for a while that was kind of messy, and we finally came up with the idea of actually splitting the user code mode into two separate interaction modes. Just very simply, there is now user code, which has no URI, and user code URI, which does have a URI. The expectations of the client instance are different in each of these cases, right? So for user code, oh, that's the slides. So for user code, you just get back the code, and the URI where you type that in is assumed to be static and known out of band. So this is for stuff that can't actually display anything. Maybe it's like talking or something like that. And displaying any kind of URI that might be dynamic is just too big of a lift for this kind of thing. So for that, we have just the plain user code. User code URI, you have a user code and a URI to go type it into. Now that URI could vary, but it is not intended to be a secret URI. It is, however, intended to be variable such that when you are, you know, say talking to a new AS or talking to a multi-tenanted system or something like that, you might get back a different URI for a different tenancy depending on what it is you're connecting and what it is you're asking for and things like that. A client asking for this mode is making the declaration that I can display not only, or I can communicate not only the user code itself, but this short URI. And the expectations from the AS are that these are both supposed to be short enough and simple enough for somebody to type in, right? These are not, 32 character random things and stuff like that. These are all meant to be very simple user typable. That is the expected and defined UX for both of these. All right. So the reason for the change is that things were ambiguous before. We think that this does make it clearer, even though it is adding another interaction mode to the possible list. It does give you a way to declare what your capabilities are at a more fine-grained model. And that fundamentally is really key to how Gnap manages all of its user interactions, right? The client instance shows up and says, this is what I can do. And the AS responds to, okay, these are the bits that I support, and this is what I can give you. So a client instance saying that it can do both of these, I can do user code or user code URI. The AS might give you different codes for both. It might only give you one of the two because you've said you can do either, and it's going to let you, it's going to let the client pick which one it actually wants to engage in, right? If the AS supports both. This does raise an interesting question, though, two interesting questions. The first is that user code, which was previously coming back as an object, is now an object with a single submember, which is always a string. So like we've done in a lot of the rest of the Gnap protocol, should this be collapsed up into just a string return value? I think so, and it would look something like that. You would just get user code and just get the string back. We need to make sure that we don't expect any other extended parameters inside of that, but I think with the new tighter definitions, I don't think that that's going to happen. That would be an additional syntax change, but I personally, I think that is a good way to go. This also raises the question, and this is relevant to a lot of the discussions we've been having in the OAuth working group recently. Does the redirects mode, is that actually a good name for it? Because redirect in Gnap doesn't actually mean redirect. It means I can communicate an arbitrary URI to the end user and get them to go there somehow. Now, I might do a redirect. I might launch their system browser. I might display a giant QR code for them to scan on a secondary device. Gnap actually doesn't make an assumption whether it's a single device or a multiple device based on this alone. All of that single and multiple device stuff, that is tied up into the interaction finish method, which is declared separately from all of this. So with that in mind, the editors are opening the bike shed discussion of should we rename the redirect mode because it's not really just redirect. It never actually was just a redirect in implementation. And as you'll see during the hackathon demo, the scannable QR code thing that Aaron has on his command line client uses the redirect mode, even though there's no redirection happening and it's on a secondary device. So do we call it arbitrary URI? What do we call it? I don't know. But that is something that we need to consider. All right. Subject information requests. This is work Fabian did to align the subject identifier and assertions with each other more than anything else. He realized when doing work on updating the subject identifier formats to be in line with the latest SEC event draft that the way we were asking for assertions and subject identifiers was they didn't match each other. So now you ask for sub-ID formats and assertion formats, and they're both lists of identifier strings, format identifier strings. But more importantly, the response now comes back using a similar structure. So subject identifier formats are defined by the SEC event draft. We are using pretty much the same kind of structure for assertion response. And right now, assertions are defined to be a single JSON string in the value with the format as the indexing key to tell you how to parse that. If there are other formats that could use other structures in there, we're open to that. We haven't seen any examples of it yet because the only ones that have come up so far have been OpenID Connect ID tokens and SAML assertions, and both of those would just get chucked into a JSON string. So this is what we have right now. We'd like to see this exercised more to figure out if it needs to be more flexible. But I do think that this is a big improvement over the previous method, which allowed you to only do one assertion of a given type, and it was a different type of indexing and formatting than what we had before. We also editorially cleaned up a lot of the text around how these things align with each other. The fact that the assertions and the identifiers should be about the same person, but they might use different identifiers. So for example, you get back an ID token that has a subject identifier, but you ask for that has the issuer and subject inside the ID token, but the subject identifier you ask for is an email address, right? And so those are different identifiers used for the same person, but it is implied by the AS as part of this contract that these are pointing to the same person. That's part of the request and response. Like I mentioned before, a whole bunch of security considerations got added. A lot of these came from the community, so thank you to Florian, I know, wrote a couple. I'm really bad at remembering names, I'm sorry. A few people wrote these. But tightening down redirect codes, bits on session management. The session management one is actually a little bit interesting. We used to have normative requirements about session management, which made absolutely no sense in practice. And so we backed off the normative requirements and turned that into a more comprehensive security considerations with advice about what to look for and how to do it that is going to depend on the type of client instance and deployment that you have. There's a really interesting attack about how you replay stolen tokens. Even though Gnap uses bound tokens by default, there's still an ability to poke a client to get it to replay a bound token. So this is also relevant for OAuth MTLS and OAuth Depop and things like that. And that's actually where the attack was first discovered, and researchers applied it to Gnap. So we've got discussion on how to mitigate that, considerations on self-contained access tokens, especially as it relates to token management inside of Gnap. So Gnap has an explicit token management layer to it that is separate from requesting the grants. And the thing, it's like the little statements that are in the OAuth revocation draft about, like, if you can't revoke a token, then the token's not revoked. Right? If you have a completely self-contained token and you try to revoke it, that's a you problem. And excuse me. And that is all. That's all recorded here now. Oh, and another big one that I have not seen nearly enough in this space is server-side request forgery. Anytime a protocol allows an input of a URI for the server to fetch, for the authorization server to go and fetch, whether that be the client's keys or, in Gnap's case, the logo and homepage and things like that. You open up a vector for an attacker to be able to craft a URI to go and fetch things. We saw exactly how bad this can be with the Log4j vulnerability earlier this year, where something was very exploitable to any deployment that was vulnerable to SSRF. So we're calling that out now. All right. For the mix-up attacks, a little bit more detail on some of these. For the mix-up attacks, the recommendation is that a client that is capable of talking to multiple ASs should use a different key for each AS. This completely prevents a whole class of attacks of the client being handed a token that was supposed to be used with one set of RSs, or was supposed to be fetched with one RS, with one AS, and actually getting it from an attacker's AS for the attacker to be able to inject it. It's a really simple thing for a client to be able to do inside of Gnap, and now we've called that out explicitly. I've already talked about most of these. I forgot that we had slides for each of these. My bad. Yeah, I already covered this. This was the user presence and session management requirement. This is errands. Error responses, these are the responses here. And one I do want to point out that I think is interesting, the last one, request denied, which is separate from user denied. That's basically the AS saying no, and I'm not going to tell you why. So if you have some reason to distrust the client instance or something else happened, this is just saying no. Like the request is over and you're done. I want to point out for anybody coming from the OAuth side, these are all error responses that come in the back channel only. The front channel does not carry any error codes at all, which already closes a huge set of potential vulnerabilities. All right. So, right. So the token rotation changes that we have in there. When you go and rotate a token through the token management system in Gnap, that means that you are getting a replacement for the token that you are rotating. That's the intended semantics of that move. If you are making a request to continue a grant with the same set of rights and permissions, you're asking for a new token to be issued as part of that grant. Now, the old token may or may not be thrown out in that case. That's kind of up to the AS, at least how it's currently written. When writing all of this, we realize, though, that we really need to have a more explicit grant lifecycle discussion, and I'll cover that in a later presentation. Sorry, it's not going. Leif, can you advance the slide?
You lost your re-requests.
Yeah, I am going to re-request.
And oh, did we lose the?
Yeah, I'm doing it right now.
Okay, there we go.
It asked me to share.
Okay.
All right, I'm gonna try and page through this. Token rotation, perfect. All right. Or is that just the last slide? Is that the last slide? That might just be the end of the presentation.
Yeah. Well, I don't see it because you're sharing. So you should be seeing the, well,
Yeah.
then it's the last. I think I think so.
Okay. All right, I think this is the last slides. Again, sorry I wasn't prepared to present this deck this morning. So anyway, that's the state of the current core draft. The editors are still working through issue backlogs and things like that. Any questions on where this is before we move to the next presentation? Nobody online?
I guess not. I'm not seeing. Somebody. So Jay Hoyla is asking. So I haven't read any of the drafts or anything, but with the confusion attacks, would it be possible to have a master key and then use a KDF to produce an independent key for each AS?
Sorry, yeah, that was me.
Oh yeah.
Well,
Go ahead.
There you go.
Yep.
So yeah, as I said, I haven't read any of the drafts or anything. But with the confusion attack a few slides before,
Yeah. I'll try to
you
pull
said
back while you're talking. Go ahead.
it says you should use a different key for each AS.
Yes.
Would it be possible to do something where you have a master key and then you use a KDF to derive a different key for each AS?
Yeah, absolutely. Yeah, absolutely. And at the end of the day, as far as Gnap is concerned, as long as the AS accepts the key for the client instance and whatever trust logic it needs in order to accept that key, as long as the AS accepts the key, it's fine. And so if you're in an ecosystem with like multiple ASs that are in like a tight federation relationship, and you can tell that this has been derived from a certain master key or it's cosigned or something like that, when that key shows up and you can verify that, that's great. Gnap actually doesn't care how that trust gets established as long as it is established. So yes, you can do exactly that.
Very cool. Thank you.
Yep.
Well, we don't have anyone else on the queue, so we might as well go ahead and.
All right.
Yeah.
And now the hackathon.
Yep.
That's the next one.
It is.
All right. So this last weekend, Aaron Parecki and I sat down in the hackathon and implemented a whole bunch of stuff. And I'm gonna tell you guys about what we did, what we learned from that, including some feedback for the drafts that we were implementing themselves, and hopefully show you guys some of this stuff live. We'll see how that goes. All right. I'm going to skip the what is Gnap slide. These are slides we wrote for the hackathon results. Our focus during the hackathon was that all the requests would be protected with HTTP signatures. We were trying to build stuff, from sort of ground up as much as we could, using existing libraries for components where they were available, building them where they weren't. And our goal was to be able to make valid requests for access tokens and get the user to interact with the AS. Now, because Gnap is such a flexible protocol, we limited our scope of what we wanted for interaction, what we wanted for access tokens and things like that. But at the end of the day, it was mostly about getting these messages along the wire. So we built a whole bunch of new code, PHP code that Aaron wrote from scratch for a CLI and a web client. He, if I recall correctly, he built the CLI first, then refactored out sort of the core bits of that, and built that into a PHP website as well that acts as a Gnap client. I built a JavaScript SPA, single page app. Again, pretty much pulling things from scratch. I had a basic React shell from previous work that I had done, threw out pretty much everything that was in the middle of it, and put that forward. In the process of this, we made significant updates to existing code that we already had that we were running against. So we had a Java-based web server client based on Java Spring. And we had a Java-based authorization server. Both of these needed to be tweaked because it turned out there were some errors and bad assumptions inside of each of those implementations. Now, we leveraged as many existing libraries as we could find, but in a lot of cases, there weren't full libraries on hand to build this stuff out. So those of you that were in the OAuth meeting the other day, the whole lack of good libraries to do things. This is as important for the component pieces of a system as it is for somebody just being able to pull down a Gnap library and go, which we wouldn't expect at this point in time. But being able to pull things down for HTTP structured fields and cryptographic primitives and things like that, that was all really important for Aaron and I to be able to build stuff. All right. What we learned is that, in particular, HTTP signatures is very complex to do from scratch. Now, I want to emphasize that last bit there. Signatures itself, HTTP message signatures itself isn't that crazy once you kind of get your head around the fact that you're doing a detached signature system. But there's a lot of moving parts. So having libraries for manipulating things like HTTP structured fields and all of those data structures goes a very, very long way. Having knowledge about how to get strings properly in and out of, or really byte arrays in and out of your platform's chosen crypto library. How to get keys in and out of that crypto library. That kind of knowledge you would need for any crypto system, and it applies to this no less. There were a couple of surprising bits that were more fiddly than we expected. In particular, turns out that the order of the parameters was not on one of the HTTP structured fields, was not being preserved on one of the platforms that we were going on. And when you're doing a cryptographic operation, if you've got parameters swapping order, semantically we didn't care what order the parameters were in, but when you've got parameters swapping order, that changes your input string. That completely breaks all of your signatures. So ideally, the end goal for HTTP message signatures, and this is, we're taking back to the HTTP working group, the end goal for that really is that it really should be transparent within HTTP library platforms. That's the layer it should be working at. I should be able to say, make an HTTP request and sign it with this key. Excuse me. I will say though, once we had that part, the rest of the Gnap protocol came together very, very quickly. I also want to point out that Aaron and I built our signing functions deliberately so that they would sign an arbitrary HTTP message. We could have hard-coded a bunch of stuff to say, okay, this is just making a Gnap request and setting the fields this way and stuff like that. Neither of us wanted to do that. We both wanted to have something that says, given an HTTP URL to go to and a key, sign this and send it. So the hackathon was as much an HTTP message signatures implementation as it was Gnap. But once we had that function in place on all of the different platforms, everything else really kind of went fairly smoothly. Gnap at its core is a JSON-based protocol with certain semantics on different fields. And so getting those JSON bits in place was definitely the easy part. And I learned that I still hate JavaScript. It's just a bad idea. All right. So things we learned from actually building this about the specs. For Gnap, we discovered that we need a way to communicate the proof parameters. So when you're doing HTTP message signatures, for example, you've got a signing algorithm and a digest algorithm and all these other sort of sub layers of that are not communicated with just the key that says do HTTP signing. Same with JWS detached signing. You would want to be able to communicate the target intended JWS algorithm inside of that as well, as opposed to just accepting whatever signed object came in, because we know that that is one of that is the basis of one of Jose's most famous misimplementations. People just accepting whatever algorithm is in the JWS structure. We realized that the life cycle is unclear when you're actually exercising the protocol, and that's why the editors are going to focus on this during the next cycle here. So the fact that we're doing at one step of the process, in some circumstances, we're doing a post with no message body. We finally took a beat and asked ourselves, why are we doing a post with no message body? Is this more semantically like a get? Does this make sense? That's the type of stuff that we need to step back and ask everybody, what does each piece actually mean, and what are we doing with it? So that is going to be the big focus for the next bit, which we'll get into in the later presentation in detail. We definitely need to externalize some of our references, like our hash reference for the interaction hash. Aaron found an existing registry we can use for that, which we're going to be changing to. We need during the hackathon, Aaron and I actually got into an interesting and lively debate about what the hash actually protects, and drew up a few diagrams. So I've already put in a PR to add the diagram that we drew during the hackathon to the draft and security considerations. And yeah, and like I mentioned, there's a little bit of semantic cleanup that some of the names might not make as much sense as we originally thought. HTTP structured values is a fantastic, fantastic spec, RFC 8941, I think it is now. It's absolutely brilliant, but it's weird because it is very HTTP-ish, and HTTP is a weird protocol. So if you're not thinking in very HTTP kind of structures and terms, it can be jarring and the first question you are going to ask is, why isn't this just JSON? There's a good reason that it's not just JSON. There's a lot of good reasons, actually. But some more starter guides for structured fields would be really good to see. And I mentioned with HTTP signatures already, this really needs to be built into the HTTP libraries, and this is something that I would like to really see happen. We are seeing a lot of uptake of developers on different platforms writing signature implementations. People have been waiting for the IETF to actually declare an HTTP message signature process for a long time now. And so we're seeing developer uptake. Hopefully it's a matter of time before those get more tightly integrated. All right, so now it's time for the demos. We have the canned demos here, but I am actually going to go and grab my laptop.
Well, live demo, not something you see every day in the IETF.
All right, so you guys get to see this fail live.
All right, let's see. I gotta approve something. All right.
Well, I
Approve the screen share from your laptop, right?
yeah, exactly. And apparently I need to. I think Meet Echo logged me out because I logged in from my phone.
Yeah. God forbid that you should overconsume IETF meetings from separate devices. There we go.
All right. And the infinite tunnel.
Yes.
All right, so here's to hoping this works. And you guys can follow along at home. If you go to gnap-c.herokuapp.com, you get the same screen. Now, this is set up to very much be an engineer's interface because as you can see here, these are all of the parameters for a Gnap request, right? Some of them are just defined in raw JSON. So I hope your mental JSON serializer is really good because it does not fail gracefully if you break your JSON. Sorry, we had a weekend. And I'm going to do a redirect mode here. I'm going to create new request. And in the background is where all the interesting stuff happened, right? This is the problem with doing a demo of a security protocol. It's you click a button and something works. All the fun stuff is happening off on the server where it's creating the messages and signing them and stuff like that. We'll be able to see a little bit more of that when I show the SPA demo in a moment. And Aaron's demo actually shows it a little bit better also. But I'm going to go here to the interaction URL. This is that redirect URI that we were talking about before. Now, up here, you can see that we are approving access to 4 different kinds of things. What's not clear from this is that the top 3 are OAuth scope style requests, so they're just simple strings. So if you have APIs that are protected with OAuth scopes, this is how Gnap represents that. The bottom one is actually that large object block, the rich authorization request style request. Gnap, of course, allows you to do them together in the same request, and so that's what's showing up here. I'm going to approve that, and then hide the form. And then, as if magic, we now have an access token from the AS that we can then use to go and at APIs and stuff like that. All of this was done using a Java-based web server. So all of the keys, secrets, and stuff like that are happening off on a back end out of the browser. So one of the things about the hackathon was that we wanted to be able to do all of this inside the browser and see what that would feel like. So this key was generated using web crypto, so navigator.credentials.createKey, whatever it is. I'm actually going to go down and so look at the end value. It starts with 2i20s. I'm going to go and this button, which you would never guess, does create a new key. So now our end value starts with MFXQ4, completely different key generated just now. This client's going to use that to make a request to the authorization server. All right. And and I do want to point out that both the SPA and the Java-based client, one of the things that they do allow is you to set your grant endpoint right at the top. So Gnap as a protocol is designed to not really require a discovery step. It is, negotiation is built into the protocol in a lot of spaces. So you just need this one URL to kick things off. Both of these clients are configurable to whatever URL you want to put on. And if you're running it, the code on localhost, I have a shortcut there because I got tired of typing that in. All right, so anyway, we are going to go create a brand new transaction. It auto redirects because I was lazy. But this is doing the same redirect based flow as we were doing before. And I'm going to go through all of that. In addition to all of the access that it's asking for, it's also asking for these two different subject identifiers for me as the user. I hit approve. And now, in addition to my access token, which is here, I also have a user information in form of an email address and then a server-specific opaque identifier. All of that came back straight to the client. This is not wrapped up in an ID token. This is not a user info call. This is information that is just dropped directly back to the client in a back channel response so that the client can just pick it up and use it. You can additionally, as we saw, do the assertions and things like that. You can, of course, call APIs that are as specialized as you want them to be. On top of this as well, just in exactly the same way that OpenID Connect does. But one of the optimizations that Gnap adds is this ability to send the subject information directly back to the client without the additional wrapping for the cases where you don't want or need that. So that's what I have for these demos. Aaron, if you're available to do your demo.
Sure. All right. I'm also going to share my screen. Oh no. Why did my permissions get reset? I have to rejoin.
It's telling us it's starting. Oh, is it permissions from your side?
Nope.
It's my Chrome permissions. I'll be right back.
Okay, Aaron is reconnecting. Any questions on that demo before we move forward?
Jonathan Hoyland, Cloudflare. This is just something that I was bringing up in chat. Again, I haven't read any of these documents or anything.
Right.
But the message format, the signatures, do they include a string that says like Gnap, such that you couldn't possibly use this interface as an oracle? Like if I have a dumb client that will just sign anything, and I've wired that up to the network, does the API require the string Gnap to always be added, or some distinguishing string, such that I can't persuade some client to sign something it shouldn't, or to produce a signature that it shouldn't, rather?
So clients in general should not be producing signatures on messages that they aren't sending themselves. So think of it more like making a TLS connection. It's only going to, your TLS stack is only going to encrypt stuff for sockets that you're connecting to. Or transport. Yaron yelled at me for calling it sockets before. I don't remember the right term. Whatever TLS does.
So TLS does include long strings saying, TLS 1.3 message. And those mean that if I'm talking to somebody malicious and I send them a signed thing, they can't then turn around and give that signed thing to some other service to pretend to be me.
Oh, okay. I think I know what you mean. I'm going to open up the console so I can show you guys what that looks like.
My demo has some details on that. It shows the actual request being signed.
Well, right. Aaron is back, but you guys talk about this and then we'll let Aaron.
Yeah, Aaron shows a lot of details, but just inside the SPA client, I know it's a little bit small here, but what's happening behind the scenes? This is the string that's actually getting signed. So HTTP message signatures is a detached signature mechanism. You generate this on both the signer and the verifier side independently based on the context of the message. All right. So when I am sending a request, I take that request message and I decide that I'm going to be signing the method, the target URI, the authorization header, the content digest header, the content type header. And then finally, these are the signature parameters for the signature that I'm creating right now. Right. All of that gets concatenated together in a very deterministic algorithm. I sign that, and then I actually send that signature. Where is it? So this is the signature value right here. Nice binary blob. Alongside the, where'd it go? The signature input line itself. So that last line of the signature gets sent out in clear text, kind of as a detached header. Those get sent side by side so that the verifier can then parse that and recreate that signed signature or that signature base, verify the signature, and go forward.
So, Aaron, I know you're on the line, but
Thank you.
I'm guessing, Yaron, do you want to comment on this particular point, or should we let Aaron run his thing? What do you want to do?
Yes, actually, I do. I'll start with the +1, that signatures are reasonably easy to write if you have a structured field library. And with Golang, I was lucky to have one. So, but otherwise, it's really difficult. And then to Jonathan's point, I support this idea. I think it's something we should consider for message signatures. In my example of an analogous context is the @sign type in JOTs. Again, to prevent confusion, mix-up attacks where people are reusing JOTs.
Okay, that was hard. They don't have that in the monitor up here, but did you guys hear that okay? Okay.
All right, so yeah, I'm trying to type to Miteko about that. But all right, so Aaron, do you want to stop?
I'm all set,
all right.
so Aaron will be sharing his side.
I'm not sure I can. I don't seem to be able to grant. Can you?
You might need to remove Justin first.
Yeah, I stopped sharing. Oh,
You
did I not?
No, I don't
Oh.
think you stopped sharing. There, well, it doesn't look like just
There, I stopped.
now.
Sorry.
There we go.
All right. All right.
Okay, tunnel vision. There we go.
There we go.
So, hi, Aaron Parecki. I want to share what I built during the hackathon. So this is going to be the two versions of the same code, the command line version and the web-based client version. Both of these are talking to the same authorization server that Justin's client was talking to. So just for context, you will see the same authorization screen because it's talking to the same Gnap server. So the command line version starts off with creating the request for what it's trying to get access to. So I have a command that's going to do that, and like I said, mine is much more verbose. So I'll explain what's going on here. This is the string that is being signed with the private key. So it generated a key that it's got in a file here, and this is the string that is being signed. So this is what ends up creating that header. This is the HTTP signatures part, which plus I guess the content digest header. And this was the
Please
part.
can you increase the font size? This is
Oh,
mostly just blur.
It's mostly a blur anyway. So
Thank you.
hopefully that helps. So this is the HTTP signatures part. This is the string being signed, talking about what URL it's talking to, the different headers being signed, et cetera, et cetera. This was the part that took the most work because I didn't find an existing library for doing the specifically HTTP signatures part. Thankfully, I did find a library for doing the actual crypto work, as well as building this header, which is the structured HTTP header spec. So it goes in, creates a signature. This is the actual post request it's making. And then here is the JSON that's part of the actual Gnap protocol. So this is where it's saying, I can send the user to a URL. I'm trying to get an access token, and here is the info about the client's key and the name of the client. The server was able to validate that, accept the key, and then created this response sending back to the client. So it's saying, go over, send the user out to this URL to continue. Or sorry, this is the URL to continue at. The command line app, this is all sort of debug up here. The command line app, what it would actually be doing is then saying to the user, visit this URL in your browser, or go to this URL, enter this code. And it can also take this complete URL and show it as a QR code, for example, which might be a little bit more friendly. So I can go and scan that QR code in my phone.
So while Aaron's scanning that, I want to point out, in case the audio was a little low, the URL that's in the QR code is not the URL that you go to enter the user code into. It is that full URL which has this randomly generated blob at the end, which we're not expecting a user to type or memorize or recognize, right? So that could be a whole encoded, encrypted, whatever thing tacked on to the end of that because it's not expected to be user facing directly. So thus the previous question of should we rename redirect, because that is the mechanism that's being used here, but it's not a redirect. Sorry for the interruption, Aaron. Please continue.
You can see my phone screen, right? Yes. Okay. So I'm looking at the same authorization screen that you saw in Justin's demo, and then I can click approve. And because there's no way for the server to send my phone back anywhere useful, it just says go back to the device. So at this point, the command line app needs to go and actually do a poll. So this little thing is in the way. There we go. So I will instead do a poll, and it's going to do a poll with to the continue endpoint, which it got back in that first response. And it sends back a token that it got in that first response and does this whole signing dance again. And because I approved the request on my phone, it actually got back the access token now. So now the app is considered logged in, and there is the access token. I guess I should have shown what happens if I don't approve the request first. So if I pull with a pending request, the response is sort of looks the same. There's no access token in this response. There's just a the continue URL. So it's basically saying try again. And if I keep doing that, it'll keep saying pending until I actually go and approve that request. So that is the command line demo. And then we can look at the same thing on the web. So now this is, I'm in a web browser, I'm talking to this application. It's actually using the same client library underneath, but now this one's running the web browser. So I'm going to click login. We're going to see the same verbose debugging of what it's sending. This time it's saying we can start the user by redirecting them somewhere, and we can finish the flow by redirecting them back to localhost 8080. So we're telling the authorization server to send the user back here after they log in, which is different from the command line, which doesn't have a way to do that. So here's the response from the authorization server saying, all right, go send the user here. And because we're in a browser, I can just put that as a link on this button. In a real app, I would obviously just send them right there with no interstitial. We click on this, we see the same approval screen, click approve, and this is going to now redirect the user back in this browser, back to the redirect URL, which you probably can't read the address bar, but up in the address bar, there is a hash and interact ref, and those two things combined work out to the client being able to say, cool, let's go make that request to the continue endpoint. This is the thing that it got in the URL, and then the response is now the access token. So now we're logged in, and there was more info in this response because I requested subject info, for example, in this app. And yeah, we're logged in the command line app now. So ta-da.
Right. 4 live demos actually worked.
Quite impressive. So we did have Sam Weiler at the queue for a little bit, but I guess he stepped away. So I think that means that we're at future work, right? Or is it? Yeah. Or is it embedding now?
It's future work.
Future work. All right.
I gotta get back. Jump back in.
I'll share and you can request control.
Midako's trying to be a little too helpful.
Mm-hmm.
And the thing is, I totally get why they do that. So should have control. All right. So now that we've just waited a beat, nobody in the queue for questions on the hackathon results. All right. Okay. So where do we go from here? That's what we're going to talk about. I put a lot into that slide. So the biggest thing that the editors did between last IETF and now is we went through all of the existing GitHub issues and triaged them and assigned little less than half of them at the time to ourselves as things that like we are going to go through and close this specific one and figure out what's going on. We're going to keep doing that. It's a lot of overhead for us, but it's also forcing us to be very thorough about how we're addressing everything. So we're gonna plan to keep doing that. But there are a couple of sort of larger issues that we know that we need to address in order for this to be a rich, full, and complete protocol. The biggest thing, and this is something that I am personally going to be taking the lead on, and that is the life cycle of these grant requests. Because right now there's an implied life cycle. You make a request, you continue it, you can update it, you can revoke it, and all this other stuff. We're just not explicit about the fact that it is stateful. It's inherently stateful. So what we're going to do is we're going to add that discussion explicitly into the spec. This may end up actually having syntactic and semantic knock-on effects to the protocol itself. Specifically, we want to be, and we know we need to be much more precise about what you're allowed to send at each stage of the protocol. So if I am doing, for example, a continuation request, am I allowed to send a new client key, like right then? That probably doesn't make any sense. Right now, you're kind of allowed to and kind of not. But if I'm making a continuation request and I send you a new interaction block, the client might actually have some additional interaction method that it realizes it can do now based on what the authorization server has told it. You know, it has new bits of information that it's saying, I can share this. So when do we allow that kind of thing? Right now, it's very ambiguous, and you're kind of allowed to send it, and the AS is kind of allowed to deal with it, however it sees fit. We need this to be, in order for this to be interoperable at this level, that needs to be much, much more precisely defined. And so that's going to be one of the biggest things that we are targeting for change between now and IETF 114 this summer. We've got a good feel for what this looks like. The editors have been discussing this for a while and have talked about different aspects of this. This is kind of the life cycle that we have in mind, right? This is a bit of a straw man. This is hardly final. But the idea being, once you create a request, if you need interaction, it goes into this pending approval state where it stays until somebody approves it, and then it's approved. That's where you get tokens, and eventually it gets thrown out. If you create a request and it doesn't need interaction, it doesn't need external approval. So this is the OAuth client credentials or assertions or some of the more advanced UMA flows that Gnap can do natively. Then you just go straight to approved, and that's where you're getting tokens. And here you can continue to pull it and get additional access tokens and things like that. However, once you're approved, there are cases where you want to update that existing grant, and that might move you back up into pending approval because you're asking for more. You're asking for additional things that haven't been approved yet. So instead of kicking you out of the system entirely and saying, go create a new thing, Gnap is designed to allow this sort of, cleaner fallback into say, okay, you're already here, just go interact again. And this is why we need to have clarity about when you're allowed to send interact blocks and things like that inside the protocol itself. So again, this is, I will be sending this diagram out to the list and hopefully starting a conversation on this as well. I surprised my co-editors with this diagram, I think, yesterday afternoon. So when I say we came up with it, I'm hoping they're not going to yell at me. But again, this is a straw man, and hopefully we can improve this.
There's a question from Jabba. Yaron says, I was going to ask if the protocol is ready to freeze to allow researchers to focus on proofs attacks, but if we're still changing the state machine, we're not ready. To be clear, I'm supportive of that.
Okay. Yeah. Thank you, Yaron. I think we're clarifying the state machine, but I agree that until this is fully formalized, we don't have quite all of the tools to do the full static formal analysis of the protocol. I think that this will actually help us a lot. Like once we get this written down, this is the kind of thing that feeds into formal analysis engines. And that will help us from a security perspective and also from a developer and implementer perspective, being able to look at this and say, like, this is where I am right now inside this process. Here's what I need to do next, right? One of the things that's great about OAuth 2 is that it tends to be a very linear state process. It's just you go, you ask, maybe you refresh, and that's kind of it. Where OAuth falls apart is that people start bolting on things to get these loopbacks back into the system, which sometimes mean just go start over from the beginning. In Gnap, we want to actually have that type of structure be explicitly declared inside here. All right. Key rotation is something we've been kind of talking about for a long time. This whole state machine, I think, will actually help us with that. We now have a much clearer model of where the keys are associated and what they're associated with inside the protocol. And this is something that I actually realized during the hackathon. The way that I'm associating keys in my implementation of the authorization server probably doesn't actually match the model implied by the specification. So I need to update my code, and we need to make the specification clearer about where these things are associated, so that people don't make the same mistakes that I did, and so that if everybody is doing this, they can do it in a predictable way, right? Key rotation needs to be handled for access tokens and potentially for client instances themselves. Since we also have different key proofing mechanisms inside of Gnap, and that is an explicitly extensible, pluggable part of the protocol, we need to be able to handle all of these different methods. Originally, the editors were trying to come up with one grand unified way to rotate keys across all proofing methods and whatnot. We actually no longer think that makes sense, because each of these different proofing methods has very, very different properties in terms of key presentation and key verification. So what we're now proposing, which we need to write the text for, what we're now proposing is different ways to handle key rotation based on the proofing mechanism that you have in use. This, of course, raises the question of, what if I want to change proofing mechanisms? Say I'm doing HTTP SIG and I need to switch to MTLS for who knows what reason. Is that something that Gnap is going to allow natively, or is Gnap going to say, if you want to do that, just start over, pretend it's a brand new key? That's a bridge we're going to have to cross when we actually get through this section. Okay, now for mandatory to implement. This is something that the editors have gone back and forth on a lot. And what we still don't have mandatory to implement text, partially because Gnap is such an incredibly flexible design. It's meant to be used in lots of different kinds of deployments. But what we think actually makes a lot of sense is to borrow something from OpenID Connect. OpenID Connect has an implementation consideration section which includes profiles that say, if you are doing this type of application, here's all of the stuff you have to include, right? And that's not to say that it is going to necessarily be like everybody follows that, but providing those base recipes, we think is, the editors are at least proposing that is a reasonable way to approach the mandatory to implement question for a protocol as flexible as this. So anybody in the queue for that? No. Okay. Extensions are another really big part of the spec. This doesn't really change the core spec. This changes how designers and implementers interact with the spec itself. Are you allowed to ignore an extension that you've never heard of? That seems like a sensible thing to do, but what if that is the extension that actually adds security? Like OAuth 2 struggles with Pixie right now. If the AS doesn't know Pixie, it ignores Pixie, and then you don't get any of the benefits, but you think you are getting them from a client perspective. So this is not as easy a question as it seems on the surface. We are at a spot in the development of Gnap that we think there's a lot that we can do to make this clearer based on what we've learned from other protocols and other systems and other stacks. And the editors are currently proposing to kind of create a section about how to add new features and functions to Gnap and what you're allowed to do with all of the different parts of the protocol. Right now, we have a bunch of scattered sections that says, and this can be extended, and it waves to IANA, and that's it. We obviously need a lot more than that, and that's what we're going to plan to do. We do think that we have really good extension points, though, from what we've seen and what we've been talking to people who are building this out into their systems right now. The ability to extend interaction methods without completely uprooting the protocol, the ability to have different proofing methods, have different user information come back. Those bits and pieces all seem to feel like those are the right places to be extended. So what we're really after here is not necessarily changing that and changing that nature of the protocol, but providing the right context and guidance around people who want to add additional stuff, what they're allowed to do, and so that implementers of the core spec can be prepared for what weird extension somebody's going to try to cram into all of these places that we say is extensible, and what you're supposed to do with that. All right. There is the lingering question of what to do with the two Jose-based key proofing mechanisms. We've kept them in core for now. This is the same slide as at IETF 112. Just bringing it up right now that this is, I think, going to be a continual question for a while. It's the only Jose dependency in all of Gnap core is this proofing mechanism. And I do think that that is a good thing, that it is limited to just this particular space. The twin questions of, does this need to be tied directly to Gnap? You know, is it something in core? Should this be an extension? And if it is an extension, is it actually something that's even more generic than just Gnap? So this is doing things in a way that's a little bit different from Depop because it is not tied into the Depop key presentation and sort of the OAuth protocol flow directly. But could this be used outside of Gnap as well? Possibly. That is a question that the community eventually needs to answer. Inertia, however, will keep these as methods inside of Gnap itself, unless there's a significant force to extract them. All right. So the resource server draft, we know it's still there. We haven't forgotten about it. It's been expired for a little bit, but that's because we haven't been doing active publication work on it. The two biggest things for the resource server draft, though, because it is a lot simpler than core, is the security, privacy, and trust considerations, like we did with the core draft last fall. We're going to do the same exercise with the RS draft. And we're also, very importantly, going to be presenting a token model. Now, this is not necessarily a token format. It could be expressed as a token format, and it can be expressed as introspection responses. But a model of what tokens represent and sort of that data structure, data model style thing of, there is a user, there are rights, there is a client, there is an AS, there are target RSs. That type of stuff needs to be enumerated and clarified and then mapped into things like JOT and introspection response. Okay, and that is all the editors had for our updates.
All right. Let's see if anybody wants to step up to the mic and ask questions or not.
George is up.
Oh, there we go. Hi, George.
Hey, can you guys
Hi,
hear
George.
me? Hey, so I just, in listening to the presentations this morning, it sounded like key rotation was proof method specific. Is there value in just basically making proofing method a sort of pluggable entity, and then Jose just becomes one of the proofing mechanisms that's supported, and that way it's sort of, you know, you can either plug it in or not based on how you want to do it. It just seemed like from a factoring perspective, you're already heading down a path of saying the proofing mechanisms are sort of unique in their own way. So you could write a standard set of way of saying, you could even write instructions like, hey, if you have a new proofing mechanism, here's the things that you need to describe, right? how you, you know, cycle keys, you know, blah, blah, blah.
Yeah. Yeah, thanks, George. That is exactly how it's written already, actually. The Jose stuff is already a separated module, if you will, as is HTTP signatures and mutual TLS. So you're already allowed to, you know, plug that in or out as you see fit. So, for example, one of the things that we did for the hackathon is we decided we were just going to use HTTP signatures as our proofing method for all of our stuff. Even though the Java AS does support the Jose methods and other stuff as well. So yeah, that is the intent, and that is hopefully something that will become more clear with the discussion on how to write extensions, like what a new proofing method needs to cover, what aspects it needs to have in order for it to be considered a valid Gnap proofing method. This also ties into the mandatory to implement discussion of, you know, if you're talking to an authorization server, can you expect for there to always be one type of proofing method that is always supported? Or is that going to be based on some other deployment profile? So yeah, it already is that type of separate module.
Cool. In that context, you had mentioned that, and obviously I checked out a long time ago, so I'm listening to try and gain some ideas or gain some familiarity. I can't talk. It's early here in the US. Is there a way when I hit that first single endpoint, since there's no real configuration, to basically ask what the proofing methods supported by the AS are?
Sorry, I had to get up to the speaker here. So the question is, can you ask what proofing methods are supported? And yes. So with that first URL, if you make an HTTP options request to that, the AS is required to send back what is effectively a discovery document.
Cool.
You can also, with the new error codes, you can also just blindly try your first request, and then if the error comes back and says like, hey, that method isn't supported, then you switch and go do stuff like that. In the wild, like we see clients doing both. We see clients like trying to pre-configure themselves and do the right thing, and we see clients that just kind of blast the thing that they know how to do, and if that fails, well, I couldn't reconfigure myself anyway. So Gnap kind of allows both types of client behavior with at least predictable results. It's not going to guarantee that it's going to work, because, you know, if a client only does Jose, then and it's talking to a server that's doing TLS, that's obviously not going to work. But there's at least predictable results when that kind of combination shows up.
Cool, thanks.
All right.
Thanks, George.
I think that means that, all right, you gotta unshare, or actually just, you could switch over to your final, the embedding thing. Run that from your, hang on. There we go.
Okay. And I think I have control. All right.
I'll be back, yes.
All right. Last presentation. I still kind of have a voice. Embedding Gnap. This is something that that I posted out to the list. We actually had a speaker about during the interim call. For this talk, I am not speaking as an editor. I'm speaking as an individual contributor to the working group. None of this carries editorial weight or consent or intent, rather. I'm not even saying that I necessarily think this is a good idea. This is a question that I think the group should consider. And so what I would like to get out of this discussion is, if the group thinks that this is something, that this is an interesting problem that we should address, let's start that. If not, then we know that we won't. All right. So there are a couple of use cases that that have been brought up that have some similar similar aspects. All right. So one that got brought up during this working group's initial boss was this idea of I'm calling an API, and the API says, wait, I need the user that's using you right now to go enter new credit card information. So I need them to go interact, go do some approval, enter some information, and then come back to me and we can keep doing the API thing. That feels a lot like a delegation protocol stepping out in the middle there, right? Even though it's kind of not, it's getting the user involved in the middle of an existing process. That's something that delegation protocols like Gnap, that's what they do. That's their entire purpose. Another use case came up recently in the verifiable credentials API special interest topic, whatever it's called in the W3C. It's not its own working group because W3C is weird. You've got a wallet presenting a VC, and the presentation API needs to go gather consent from the user. And in order to do that, it needs to be able to get the user in front of some other piece of software for the user to say, hi, it's me, I'm okay with this, this, and this. Okay, go, right? In some cases, the user might log in. In some cases, the user might present a separate set of VCs to this in sort of this, change transaction thing. Regardless, once the user says go, then they actually need to come back and the app needs to finish calling the API exactly like it always has. So the reason that I think that this is interesting is that protocols like Gnap are never used on their own. Like nobody ever runs a security protocol for the sake of running a security protocol, unless you're a couple of nerds at a hackathon last weekend, but that doesn't count. In the real world, you're either protecting an API, you're gathering user information, or you're just doing something, and the security protocol is your means of doing that, right? Or it's part of your means of doing that, and that is actually really important. How Gnap fits in with other protocols and ecosystems is intentionally flexible because we've learned a lot from how OAuth 2 has been used over the years, both as part of OpenID Connect and on its own, and as part of other systems. So we've got two models today. I'm going to go through three different models. We've got two that exist today. We either have a traditional delegation. We can embed protocols inside of Gnap itself. And I want to raise the question of, does it make sense to embed Gnap inside of another protocol? So what do those look like? With traditional delegation, you go try to do the protocol, your end target protocol. You try to go do that, and you fail, and you get told to go talk to an authorization server, do whatever that says, and then come try again. Come back with an access token and talk to me to prove that you've done this. All right? This is really simple from a protocol design perspective. Like, we all know how this works. We've been doing this for a very, very, very long time. Gnap fits completely in that box in the middle and does not really touch the outside of the protocol except for that www auth header that indicates go start the Gnap process. And otherwise, that's pretty much it. This is plain vanilla API access. So the benefits of this is that it separates the layers very cleanly. And that is a really, really big benefit, to be clear. The Gnap layer and the protocol layer don't really have to know anything about each other. They don't have to deal with each other. Separate set of concerns. And it's usable without modifying either protocol. Like, Gnap doesn't have to do anything special. The protocol doesn't have to do anything special except say that it's protected by access tokens and knows how to kick this off, right? But it doesn't need to, the protocol doesn't need to know anything about how the user interacted or what's being requested or anything like that if it doesn't want to. And another huge benefit here is that you can do this against multiple protocols at once. This abstraction layer across security across different APIs is one of the biggest things that delegation protocols like Gnap and OAuth really, really give us. The downside is this is very chatty. There's a lot of back and forth. There's a lot of discrete steps when you know the end result that you're trying to get to. And it's really, really inefficient for the simple cases like going and getting an credit card information. Like, I'm not really asking for additional access to the API at that point. It's just that's the only means the API has. If we're doing this, the only means the API has for getting the user involved is to say, your access token failed, quote unquote, go tell the user, right? So then there's the case of embedding protocols inside of Gnap itself. So you start a Gnap process, but then with extensions, probably through the interaction methods, you're actually going to go do a totally different protocol inside the context of Gnap. And then you're going to return the results of that as part of the Gnap response. Gnap is built to be extended in exactly this way. The reason for this is exactly what OpenID Connect did to OAuth 2. You go start off the Gnap process, make your grant request, and say, I can do the foo API for my interaction method. This is how I can get the user involved. And so I'm going to go do that foo protocol, and I can do whatever I need to do, whether that's exchanging VCs or calling backend fabrics to post information or doing key exchanges. Gnap doesn't care during this phase. Like, it's whatever extensions you want to be able to do there. And then you kick off this interaction finish portion of the Gnap protocol, which Gnap can then take over and say, all right, now that that's done, hey, I've got this extra chunk of information that I can return directly to you at the client as part of the Gnap response. The most obvious way to use this is for things like identity information. So I'm going and I'm doing a negotiation for which types of user claims and attributes that I'm asking for, and I'm getting back signed assertions that I can then use as part of federation transactions, right? The downside is that this is a very specialized integration that assumes that you are doing Gnap right from the start, which is a really, really funny thing to think of if somebody is trying to go and actually do something else. So if somebody just wants to call their, purchase API, embedding that every time inside of a Gnap request makes no sense, especially in the cases where it's just going to go through, right? You already have all of the information. This is a whole other extra layer of overhead, which is why the login case makes sense, because you're kicking off a brand new process when you're going to get login information. So it makes sense that you might have to do some additional stuff to get there. When you're calling other kinds of APIs, it doesn't make nearly as much sense. So that brings us to the third and, in my opinion, weirdest case of embedding Gnap inside of a different protocol. So we start at the protocol, and then we get kicked out of the protocol and start doing Gnap stuff sort of already in process, already in progress. And then we do that for a bit, and then we land back at the original protocol. Now, what this looks like, this absolutely looks weird. This looks really funny. But this is the way that these use cases keep getting described. And this is why I think this is fascinating. Because I go to call the API, and I'm just doing the native API call, whatever that is, not even necessarily access tokens. I'm just calling the API and doing that. And then the API says, hey, I have figured out that I need to get the user in front of me somehow. So here is a Gnap response block. It's got interaction and continuation and all of that other stuff that Gnap defines. Go process this. And to process that, you go and you start doing Gnap. You follow the interaction stuff, you do the token continuation, you do all of that stuff. And then when that has been fulfilled, the API call comes back with the native API response. So the thing that you were asking for in the first place, it's a VC, it's the purchase completion, it's whatever. This is not something embedded inside of a Gnap response anymore. This is the native target API. Now, the upside of this is that this is a really efficient use of the Gnap security components, because you're only using the bits that are relevant to you. Like, you're getting the user in front of something else, you are managing the state of that request over time, and then you're getting out of the way. And calling the protocol natively at the start and at the end, that feels right, because that's what the developer is ultimately trying to do. They're not trying to get access to the API. They already have access to the API. There's just an additional bit of user interaction and consent and other stuff that they need to gather in the middle of that API. So the downsides is that this is a really strange specialized integration, and Gnap was never meant to start halfway through like this. Like, the Gnap process is always, you start it exactly the same way, and then you branch off into all of these different options. That is a fundamental pillar of Gnap's design. All right. Every version of this is going to depend on the protocol that it's being embedded in. So that Gnap response coming back, you know, it's going to look different. What if I'm calling an API that speaks XML or speaks COSI or speaks something else? Gnap is defined in JSON over HTTP. So if I'm getting a JSON blob embedded in some other protocol definition, that means I now need to sort of roughly shift gears to go do this other thing. That feels very strange. And what we're seeing right now, with the handful of places that are doing stuff like this, is that instead of embedding Gnap, they're actually claiming inspiration from Gnap and doing this interaction type stuff, right? So my question to the community, to the working group, is this something we care about? It hasn't been brought up a lot, but it's been brought up at least twice, which is interesting in very different contexts. And my question to the group that I think we should consider is, are the extension points that we have sufficient? Should we explicitly consider this case of pulling like the middle bits of Gnap out and saying how people should use it in that way? Or is this something that we just are silent on, and if people take inspiration from Gnap, that's good enough? Do we even care? So that's my question. I don't have those answers.
Jonathan Hoylands, Cloudflare. This, I mean, obviously people think I say this about everything, but this looks like a place where you'd use channel bindings and importers and exporters, because what you're actually trying to do is not produce one sort of super big protocol. You're trying to say, we want to, in a principled way, get some security guarantee from using Gnap or using some other protocol inside Gnap, and transfer that between the two protocols. And rather than trying to come up with a sort of one-size-fits-all solution, you should, or you could, produce an importer interface where people can import keys and an exporter interface where people can take keys out that give you those guarantees when used. Yeah, anyway. So it could be done in a principled way if you want to do formal analysis stuff.
Right. Thank you. I'm not sure I fully understand that response as to what the key import and export binding would have to do with this, because I think we might be talking past each other.
So if you have this sort of protocol in the middle, rather than trying to say define your foo protocol Gnap interface in a draft and then going away and using it, you could just say Gnap has this API call that you can make at the beginning and produces some output at the end. And then foo just has to be able to use those two without understanding anything about Gnap or defining anything about
Isn't
Gnap.
that the other?
Yeah, that's What you're describing is this.
Okay, yeah, but my point is you could do it in a formal analysis style.
Okay, thank you. So the embedded Gnap, just to be clear, is basically an optimization of this model, where you sort of slice off the top and bottom of that box in the middle in order to make it more streamlined and compact, at least in theory, right? And the main reason for this is that you are no longer, in the proposed use cases, you are no longer really calling a protected API. You are just kicking off for user interaction and coming back. And the answer may very well be we just tell all of these groups, go figure it out on your own. That's your protocol. If you don't want to fully step out into delegation space, then that's not our problem. That might very well be the right answer, and I would be fine with that. But because this has come up a few times, people have looked at Gnap and said, maybe I can use parts of it. I think we should at least have an answer for that.
So Aaron, do you want to, or sorry, Yaron, do you want to jump in?
Yeah, so let me check if you can hear me.
Sorry.
Can you?
Yes, I can hear you. I just have to stand by the speaker.
All right, so I think this can become very complicated very quickly, and we should avoid it now. We're still figuring out our own state machine. The security integration, which Jonathan alluded to, is complicated. Maybe it's doable, maybe it's not. I think it would just hold us back, and we shouldn't look at this before the V1 is out.
So if those of you in the room didn't hear, Yaron's take was that we should not look at this until V1 is done, which is a totally reasonable take. And honestly, kind of something I personally lean towards, but I wanted to make sure that this was written down and we considered if this was worth it.
All right, that's it. Yeah, and I think that gets us. I'm gonna put the share slides back just for the hell of it, and yeah. So that gets us to the end of our content for today, and we didn't actually put up a slide that says open mic, but this is it, right? So if somebody has anything they want to raise, otherwise we're out of here early, and hopefully meet again. Well, Jaron, have we decided on interims? I don't think we have decided on interims yet.
No, we have not.
No, but we will definitely discuss that on the list, and it's like very likely that we'll do further interims before Philadelphia. But hope to see more of you in Philadelphia for IETF 114. And I think that's not seeing anybody running to the mics or up to the queue, so I think that's it. And thank you all for coming. All right. Yeah. Are you you're gonna go to OSW in Trondheim.
Yes.
So I'm
Gonna plan to be there.
sending a few of my guys there.
Oh, nice.
One of them, well, a couple of them are really good. Ivan and Kushal, who you might have talked to. I don't know, maybe. But say hi to them. They're going to be involved in a lot of the wallet work and stuff like that. And they're really smart people.
Nice.
So,
Yeah, a lot of the there's a few different people in the wallet space that are implementing Gnap for
yeah.
authorization because OAuth doesn't